Namaste to everyone. Welcome to all to my YouTube channel. Today I will deliver lecture on tensor analysis, lecture number 2, which will include the problems and examples of dummy suffix, Kronecker Delta, Contravariant vectors, Covariant vectors, etc. First, I am giving a problem. The problem is to prove del xi by del xj, that is partial derivative of xi with respect to xj, equal to Kronecker delta. Since coordinates of a point P is denoted by x1, x2, xi, xj, xn. If xi equal to xj, then del xi by del xj equal to del xi by del xi equal to 1. Again, since xi and xj are not equal and they are independent coordinates, so del xi by del xj equal to 0. From these two concepts, we may conclude that del xi by del xj equal to 1 for I equal to j, equal to 0 for I not equal to g. Again, we know that Kronecker delta ij equal to 1 for I equal to j and equal to 0 for I not equal to j. So from 1, this is 1 and this is 2, we get that the result is same. So we may conclude that del xi by del xj equal to delta ij. Proved. Our next concept and problem is, aj delta ij equal to ai. Here delta ij is the Kronecker delta. We may write here the left side, in which we get that j is a repeated suffix. We know that repeated suffix is dummy suffix. So according to Einstein summation convention, we may write this in summation form, that is equal to a, value of j is 1, delta I1. Again, value of j is 2, a 2 delta I2 plus ith term ai delta II plus an delta in. Here in the right hand side we see that the value of I not equal to 1, value of I not equal to 2. This gives that delta I1 equal to 0. Similarly, delta I2 equal to 0. Here in ith term, particular value of ith term, we get delta II, this is 1, and delta In equal to 0. So we write this value A1 into 0, A2 into 0, plus AI into 1, plus all values 0, An into 0. So we get only AI. Proved. Our next problem is if a bar I, this is contravariant vector, equal to del x bar I by del x alpha, a alpha, then we have to prove that a alpha contravariant vector in x system of coordinates, this is equal to del x alpha by del x bar I, a bar I. This is the contravariant vector in x bar system of coordinates, and this is contravariant vector in x system of coordinates. So we write this by expanding values of alpha equal to 1, 2, this is repeated suffix. So we write this as a bar I equal to del x bar I by del x1 a1 plus del x bar I by del x alpha, del x2, value of alpha is 2, a2. Now value of alpha is 3, del x bar I by del x3 a3 plus del x bar I by del x beta a beta ith term plus del x bar I by del x n am. Putting values of I equal to 1, we get a bar 1 equal to del x bar 1 by del x1 a1, del x bar 1 by del x2 a2 plus del x bar 1 by del x beta a beta plus del x bar 1 by del x n a n. Again putting I equal to 2, A bar 2 equal to del x bar 2 by del x1 A1 plus del x bar 2 by del x2 A2 plus del x bar 2 by del x beta A beta plus del x bar 2 by del x n A n, and similarly we may write values of I equal to n, A bar n equal to del x bar n by del x1 A1 plus del x bar n by del x2 A2 plus del x bar n by del x beta A beta plus plus del x bar n by del x n A n. Now multiplying first equation by del x alpha by del x bar 1, multiplying second equation by del x alpha by del x bar 2, and so on. The last equation we multiply del x alpha by del x bar n. Then adding these equations, left side first and then the right side, we get A bar 1 into del x alpha by del x bar 1, that is del x alpha by del x bar 1 A bar 1, then adding second del x alpha by del x bar 2 A bar 2 plus del x alpha by del x bar n A bar n, del x alpha by del x bar n A bar n equal to, now multiplying first terms of each equations by del x alpha by del x bar 1, del x alpha by del x bar 2, and del x bar alpha by del x bar n, and then adding these del x alpha by del x bar 1, del x bar 1 by del x1 into A1, we write by taking comma as in the second term, second line also we get A1. So add the second line multiplying by del x alpha by del x bar 2 del x alpha by del x bar 2 A1 and del x bar 2 by del x 1 and so on, del x alpha by del x bar n, del x bar n by del x1. A1 is common. In each term we get A1 here. Similarly, these terms multiplying by this and this and then adding del x alpha by del x bar 1 into del x bar 1 by del x2 plus del x alpha by del x bar 2 del x bar 2 by del x2 plus del x alpha by del x bar n into del x2 del x alpha by del x bar n del x bar n by del x2 common A2 in each term plus plus we get these terms. So del x alpha by del x bar 1 into del x bar 1 by del x beta plus del x alpha by del x bar 2 into del x bar 2 by del x beta and so on, del x alpha by del x bar n del x bar n by del x beta common A beta. Now last line. Del x alpha by del x bar 1 del x bar 1 by del x n plus del x alpha by del x bar 2 del x bar 2 by del x n plus del x alpha by del x bar n del x bar n by del x n and common is an. Here we get that 1 is repeated 1 1 2 2 n n. So it represents the dummy suffix. We may write left hand side as del x alpha by del x bar I, dummy suffix, a bar I. This is left side. I equal to 1 1 plus I equal to 2 2 plus dot dot I equal to n. Now here first line we see that this is del x alpha by del x bar 1, del x bar 1 by del x 1, del x alpha by del x bar 2, del x bar 2 by del x 1. So this is the derivative of x alpha with respect to x1. So we may write del x alpha by del x1 a1. Similarly, in the second line we also get del x alpha by del x bar 1, del x bar 1 by del x bar 2, again del x alpha by del x bar 2, del x bar 2 by del x 2, and so on up to nth term. So this is the derivative of x alpha with respect to x2. So we write del x alpha by del x2 a2 plus dot dot. This line represents del x alpha by del x beta a beta plus dot dot dot. This line represents del x alpha by del x n a n. This is called Kronecker Delta, as we have seen earlier, plus this is also Kronecker Delta alpha 2 a2. This is Kronecker Delta alpha beta a beta. This is Kronecker Delta alpha n n. Here alpha not equal to 1, that means value of this Kronecker Delta is 0. Here also similarly we get 0. Here if beta equal to alpha, then this value of this is 1, and here alpha not equal to n, this is 0. So we may write 0 into a1 plus 0 into a2 plus dot dot dot. This is 1 for beta equal to alpha. So here in place of beta we write alpha plus dot 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 0 into a n equal to a alpha. So our problem is proved. Next question is to prove that the velocity of a fluid is a contravariant vector. As fluid flows, so let the coordinates of a particle which is moving is taken as x1t, x2t, xn t at the moment t. This coordinate is considered in x system of coordinates. X system of coordinates. X system of coordinates. Its corresponding value in x bar system of coordinates be x bar 1t, x bar 2t, x bar n t. This is in x bar system of coordinates. We know that velocity with respect to x1 coordinates is dx1 by dt, dx2 by dt, and dxn by dt in x system of coordinates. This velocity may be written as v1, v2, vn. So, in x system of coordinates, the velocity may be written as generalized form vi equal to dxi by dt, and in x bar system of coordinates v bar I equal to dx bar I by dt. We know that the relation between two systems of coordinates, x bar system of coordinates depends on coordinates of x systems. For example, x bar I is the function of x1, x2, xn. If we differentiate this with respect to time in both sides, dx bar I by dt equal to del x bar I by del x1 dx1 by dt plus del x bar I by del x2 dx2 by dt and lastly del x bar I by del xn dxn by dt. Here we see that 1, 1, 2, 2, n, n. So it represents the dummy suffix. We may write this as del x bar I by del x alpha dx alpha by dt. Left side is written as v bar I equal to del x bar I by del x alpha v alpha. This partial derivative represents that velocity vectors are contravariant vector. Thank you to all for watching my video. Some problems are dealt here. We have some remaining problems also. We will deal in next lecture. Thank you. If you are satisfied with my YouTube and videos, then click on like button and do subscribe my YouTube channel. Thank you.